These are notes for section 4.4, day 3 for pre-calc. We've been looking at transforming our sine and cosine graphs. And what did our A value do to our graph? Okay, so vertical stretching or shrinking. What made it stretch? Bigger than 1, shrinking between 0 and 1? All right, what if it was negative? Reflects over the x-axis. Okay, moving on to B. What does B do to my sine graph? Now we're doing a horizontal stretch or compression. And remember, those go in opposite of what we think they should be. So as B gets bigger than 1, what happens? We actually compress our graph. Yes? All right. We are going to look in the second half of today's notes at what happens when B is negative. We haven't encountered that yet. All right. What did the H do? That's called a phase shift, or left or right. Notice in this equation that your H, this is factored away from your B term. Yes? A lot of times it's not in that format when we first look at our equation. Today we're going to look at how do we get it in that format so we can really see that phase shift. All right. And now today we're going to add in a K value. What did K used to do? Shifts up or down. Does the same thing. All right. So K is going to be a vertical shift. If it's positive, it's going to move our graph up. If it's negative, it's going to move our graph down. Now, sine and cosine curves normally oscillate around the x-axis, right? So we'll just take a sine curve. It goes up A and then down to negative A and back up to 0. So we went up to a positive A value and we went to a negative A value, and we oscillated around that x-axis. So it looks symmetric to it, same distance above and below. What we're going to look at today is what happens when we shift that dotted line. So that red dotted line now is going to move up and down, and it's going to take my graph and move it up and down with it. Okay, so it's no longer going to be symmetric to the x-axis. It's going to be symmetric to our new 0, and I'm saying that with quotes around it. All right, we're going to take what we think of as our 0 line, and we're just going to start moving it up and down. All right. So when we talk about the range of our graph, and it is important, especially when we start talking about vertical shifts, that we know what is high and what is low. It's not going to be the same value anymore. Okay, before we could say, well, we're just bouncing between 3 and negative 3. All right, now we're going to start shifting off of that 0 line, off of the x-axis, and so the range values are going to be 2 different numbers. Okay, we can find it by taking whatever our new line is and adding and subtracting our A value from it. Okay, so we're going to take that new K value and we're going to subtract A to find our low value, and we're going to add A to find our high value. All right. So you'll notice that our directions get longer and longer. Now that we have more pieces involved in our equation, there's more things that we have to find. In example 8, it says we need to find the amplitude, the period, the phase shift, the vertical shift, the range, and we need to graph it. Okay? So let the fun begin. What can we tell about the amplitude? Okay, we know that from last week. Our amplitude equals 4. It is a sine curve. How about period? It's always 2 pi divided by b. In this case, b is 3, so we're getting a period of 2 pi over 3, or 2/3 pi. Okay. Have we done any kind of phase shift? Any left or right shift? No, there's no h value in my equation. All right, it makes this one a little bit easier. How about a vertical shift? Have we moved up or down at all?
Down.
We have moved down 2 based on that last minus 2. So vertical shift, down 2. All right. in order to figure out our graph, we also need to know our increments. This one gets a little bit messier because our period was 2 pi over 3, and we have to cut that into 4 equal chunks, right? So dividing by 4 is the same as timesing by 1/4. So what is 2 pi over 3 times 1/4? We get 2 pi over 12, which is pi over 6. So our increments are going to be in pi over 6s. Okay? But we haven't done any kind of phase shift. So we're really going to start at 0. We haven't moved off of that at all. We're going to start at 0, and our increments are going to go in pi over 6s. So our first mark is pi over 6. Next mark would be 2/6, which is pi over 3. Our next mark would be 3/6, or pi over 2. And our next mark would be 4/6, which would be 2/3. 4/6 is 2/3, which is where we thought we should end, right? Okay. Now, we have done a vertical shift down 2. So I want you to draw a dotted line down here at y equals -2. We're going to think of that as our new 0. So when I say it's a sine curve, sine starts at 0, we have to start at our new 0. Okay? So our first dot is going to be down there at -2. And if this gets too confusing to do all of the moves at once, you can do them in pieces, right? You could put your original dots on there and then shift them all down too if you want. Okay, we're going to try to do it all in one step. From 0, our sine curve usually goes up, right? Have we done any kind of reflection where we have to worry about not moving up? Okay, so our next dot will be up at what is considered our high point. Okay, well, what is our high point? We have an amplitude of 4, which means from that dotted line, we need to go up 4. So if we go up 4, we're up here at +2. So that's my high. Okay, then I go back to 0, my new 0. What would low be? If we have to go 4 down from that dotted line, we're going to be at -6. Okay, so my next dot is down here. And then my last dot is back on my dotted line. So can you see that we've taken this sine curve, we've done several things to it. We've stretched it vertically, we've compressed it horizontally, and now we've shifted it down. Does it look symmetric to this dotted line? In other words, we're bouncing the same amount up as we are down? Yes? So what is the range of my graph? What was my lowest value? -6, and my highest dot was at 2? Okay, so if we wanted to figure that out before we even graphed anything, we can take our k value of -2 and add and subtract our a value. Okay, so k plus or minus our a value. So -2 minus 4 gives us that -6, -2 plus 4 gives us the 2. Okay, so it makes sense that my graph is going to be in between that -6 to 2 range. Okay, bless you. All right, we're going to actually go down to number C right below that. It's another one that doesn't have a phase shift, so we'll get the hang of our vertical shifts a little bit here. What is the amplitude on this one? 3. Okay, period. We take 2 pi and divide it by 2. So period is pi, which means our increments are going to be pi over 4s. Okay. Have we done any kind of left or right shift? No, so no phase shift. Okay. Vertical shift. What have we done? Down 1. Good. All right. Let's go ahead and figure out our range right away. We said our move down is down 1, so we're going to have a dotted line down here at -1. And we need to go 3 up and 3 down from that line. Where do we land if we go 3 up? We land here at 2. And if we go 3 down from our dotted line, we're at -4. Okay, so our range, again, can be found by taking our k value and adding and subtracting our a value. So we are getting -4 to +2 as our range. Okay? All right, let's get our tick marks labeled. We are going in increments of pi/4. We haven't done any kind of left or right move, so we're going to just start from 0. My first tick mark then would be pi/4. Next one would be 2/4, which is pi/2. And then we have 3/4. And then we have 1 pi. Okay. So that's 1 period, and I've only been graphing 1 period in our notes, but you can extend it, right? You could just copy the same thing you graphed there one more time. Yes, no? Okay. Let's get our dots on there. It's a cosine curve. So cosine normally starts where? Normally starts at 1, or if we have some kind of vertical stretch, it starts at our high point, right? Cosine normally starts high, then goes to 0, then low, then 0, then high. Okay, so what is our high point here? Our +2. So our first dot is going to be up here at 2. My next tick mark, I'm going to be down at what is my new 0, which in this case is -1. My next dot would be my low point, which we said was -4, and then back to 0, which in this case is -1, and back to high point, which is our 2. Okay? Yes? All right. So what happens now when we add a phase shift in there? Well, we're going to break it down here. Amplitude would be 3 again. Period. We have 2 pi and it's getting divided by 2. So period is 1 pi with increments in pi/4. All right. Our phase shift. Now, you have to be kind of careful here because to identify the phase shift, this b term has to be factored out. Okay? So let's look at this 2x minus pi/2. If we factored a 2 out of that, what would we get? We'd have x minus. Factoring a 2 out just means we're dividing everything by 2, right? We're moving out front. So 2x divided by 2 is 1x. Pi/2 divided by 2 is pi/4. So what have we really done for a phase shift? We've moved right pi/4. Yep. Now, this is nice because our phase shift is pi/4. Our increments were going in pi/4, so everything's going to be nice and clean. And then our last piece, we had a vertical stretch, or sorry, a vertical shift of what? Down 1 again. Okay, so let's get our dotted line here at -1. Our amplitude is 3, so this is kind of like the C example that we just did, right? What's our range going to be? Our k value plus and minus 3. So we go from -4 to +2. All right. So let's put some arrows on here. So we're going to bounce between that -4 and +2. All right. Let's figure out where we start and stop. We said that we are shifting to the right pi/4, and our tick marks are going in pi/4s. So we're actually going to start here. And then each tick mark is going to go pi/4s. So add another fourth, we're at pi/2, 3 pi/4, 4 pi/4, which is just a pi, and then 5/4. Now let's see if that makes sense. I'm going to do some moving here. All right. We had in our original problem that piece right there, 2x minus pi/2. Let's think about what we had done last week. We took 2x minus pi/2, and we said normally it goes between 0 and 2 pi for one period. What did we need to do to solve this for x? Okay, first add pi/2 to both sides. So we get pi/2 is less than or equal to 2x, less than or equal to what? What's 2 pi plus another half? Right? 2 pi is 4 halves. Adding one more half is 5 halves. And then our last piece was to divide by 2's. So we get pi/4 up to 5 pi/4, which is what we are just coming up with on our tick marks here, yes? We're going to start at pi/4, we're going to stop at 5 pi/4. All right, let's get our dots put on there. It's a sine curve again, so sine starts on our 0 line, which again is our new dotted line here that I have drawn in. So at pi/4, we're going to have a dot here at our new 0, and sine goes up from there. So we're going to go up to our high point, which amplitude is 3, so 3 spaces above that. We're up at 2, back to our new 0 line, down to our low point, which is 3 spaces below that line, and then back to our line. So this one has had a lot of things done to it. We've stretched it vertically, we've compressed it horizontally, we've shifted it to the right, and we've shifted it down. A little of everything. Okay, let's try one more that has a phase shift in it. Okay, it is a cosine graph. What's my amplitude on this one? So we haven't really done any kind of vertical stretch or compression, right? This is just a standard graph. How about B? What's my B value? My B value is 1, which means the period is just plain 2 pi, right? We haven't changed that at all, so we have no horizontal stretch or compression. Increments then would be going by what? Everybody? pi/2. Okay. What happens inside the parentheses? What does that tell me? I have a phase shift of what? Because it's a minus sign, we're going to the right. Right pi. And last piece, our vertical shift. Everybody, come on. Down 1. Okay, so let's get our dotted line down 1. How about the range? We start out with our k value of -1. We're going to add and subtract our a value of 1. So we end up with, I heard it earlier, -2 to 0. Okay. So on my graph, I'm going to bounce from -2 to 0 inside that window. All right. We said that we are doing a normal period of 2 pi, but we are shifting to the right 1 pi. So if we take our x minus pi and say it used to be from 0 to 2 pi, adding pi to both sides, we are now going from pi up to 3 pi. Okay, still a span of 2 pi, which is what the period is supposed to be, but we've moved it to the right. Our increments, our tick marks, we said, should go by pi over 2's. So pi would actually be here. Okay, so that's going to be my new starting tick mark. And we're going by pi over 2's. So this is 2 halves. This would be 3 halves. 4 halves would be 2 pi. Then we have 5 halves. And then we have 6 halves, which is 3. Okay, so we're starting at pi, we're ending at 3 pi. Okay? All right, was it sine or cosine? It was cosine. So cosine starts at our high point? Yes? Okay. So what's high in this case? High is 0? Okay. So my first tick mark here at pi, my high point is going to be 0. Then I go to my line. Then I go to my low point, which we said was -2. Back to my 0 line. And back to my high point. If I asked you to draw one more period, what would your last tick mark be? Where would our last tick mark be? At 5 pi, right? Our period is 2 pi. If we stopped here at 3 pi, 2 pi more would be 5 pi. Okay. So 1, 2, 3, 4. That would be the end of my next period. Yes? Okay. So if I had to continue, I'd go down to 0, low, 0, high. That would be the second period that I would draw. Does that make sense? Okay. All right, so now we're going to look at what happens when b is negative. What does it usually mean in a transformation if b is negative? Yes, we have to reflect over the y-axis. Now think about all the things that we've just been figuring out. We had one more piece in there of having to reflect over the y-axis. It gets messy. All right, it's much harder to get all of that done in one, especially if we had a reflection over x on top of a reflection over y. Okay, it almost just gets to be too much. So there's a way to get around it for sine and cosine graphs because we know what kind of symmetry they have. It says when b is a negative value in standard transformation form, we can use the fact that the sine is an odd function and cosine is an even function to simplify our equation before we even start breaking it down. Using these properties will avoid physically having to reflect it over that y-axis. Okay? So think back a few chapters. We defined an odd function to be one that if you put a negative value in for x, you get the opposite of what you got when you put the positive value in. Okay? Now, sine is an odd function. If we think about its graph, it looks like that, right? If we extended it to the left, it would look like that. Okay. It has symmetry to the origin, or that rotational symmetry. We can spin it and it lands back on itself. So what we can do is, if there's a negative here for b, we can think of it as the equivalent equation where the negative has been pulled out front. Which means instead of thinking of reflecting this over the y-axis, where this part here would reflect and become this, yes? That's the same as if I just reflected over x. So picture taking the dotted black portion, reflected over x, it's going to land up where that new blue piece was. Does that make sense? So reflecting over y is really going to give me the same curve as if I reflected over x, because it's an odd function. So for sine curves, if you have a b value that's negative, you want to get it factored away from your x and then bring it all the way out front. Okay? So what I mean by that, let's look at our first example here. We want to convert this equation. We're going to actually pull the -2 out away from all this stuff in parentheses. It's still going to be inside, but it's going to be out of the very innermost set of parentheses. So if we divide -2x by -2, we just get a plain x. What do we get if we divide this -pi/2 by -2? A negative divided by a negative is going to be positive, right? And dividing pi/2 by another 2 gives us pi/4. Okay? And then we still have the -3 on the very outside. And what we just talked about, because sine is an odd function, this negative sign right here can get pulled out and put in the front. All right? So we're going to pull that out and put a negative out front there. Well, what happens with a negative? So instead of having it initially being reflected over x, and then this second negative here in front of our 2 is going to reflect it over x again, it's going to put it back, right? If you take a curve reflected over x and then reflected over x again, we're back where we were. So my new version of all of this is it's just a plain 3 in front times the sine of a 2, a quantity x plus pi/4, and then a -3 on the end. Okay? So describe this graph to me. Vertical stretch of 3. Our amplitude is 3. Okay, so we stretched it vertically by 3. Then what? Very good. Period is going to be 2 pi divided by our b term of 2, or just 1 pi, which means increments are going to be pi/4s. Okay? Good. We went left, phase shift. We went left pi/4. And our last is a vertical shift. What did we say? Down 3? Okay. So take a minute, figure out your range. All right. Are you getting a range of -6 to 0? Good. So have we identified everything that we would need to do in order to get our picture drawn? All right. Where should my dotted line go? At -3. Okay. We are bouncing between -6 and 0 for our range. All right, let's look at where we are starting and stopping. Inside the parentheses next to the word sine, we have 2 parentheses x plus pi/4. Now this one, we would solve it a little bit different. Our normal start and end is 0 and 2 pi. But because we've factored that 2 out, that's the first thing I have to get rid of. So I'm going to have to divide everything by a 2. Well, 0 divided by 2 is still 0. If I divide this middle chunk by 2, I just get the x plus pi/4. And divide the end here on the right by 2, I get 1 pi. Now I can subtract a pi/4 to both ends. What's pi minus pi/4? Okay. Is that still a span of 1 pi? From -1/4 to +3/4? is a span of 4/4, okay? And that we said the period should be pi, our increments should be pi over 4s. So we are going to start over here at negative pi over 4, and we're going to go by pi over 4 increments. So my next tick mark is going to be at 0. Then my tick mark is at pi over 4. Then 2/4, which would be pi over 2, and then 3/4. All right. So do I have 5 labels for my 5 key points? All right. What kind of graph are we doing? A sine curve. Sine starts at 0, or our new 0, our new dotted line. So at my very first tick mark over here at negative pi over 4, I am down here, right, at negative 3. That's my new 0. Then I move up to my high point. Amplitude is 3, so 3 spaces above there. Back down to my 0 line, to my low point, which we said was going to be a negative 6, and back up to 0. Questions on that? Okay. Let's look at what happens with cosine. Cosine is an even function. We start high, right? Go to 0, go to low, back to 0, back to high. There's one period. If I extended it on the other side, right, looks like that. Because it's an even function, the value I get from my function when I put a negative x in is the exact same thing I get when I put a positive x in. Okay, think of other even functions like squaring. X squared is an even function. Okay. If you think in terms of the unit circle, let's say we went up pi over 4 radians. Our ordered pair for x is negative 2 over 2. Yes? If I go down pi over 4 radians, okay, in a negative direction, my x coordinate is still root 2 over 2. My y changes, right? So over here when we were talking about sine, our sine value changed to the opposite, but our cosine doesn't. It's the same cosine value. So if there's a negative b term in here, we can basically get rid of it. Now I want to caution you, you have to physically factor it out from your h piece before you can get rid of it. Okay, because it's factoring a negative out is going to change your signs. But once you've factored it out, it can go away. All right, so how that looks. We're going to rewrite this one by factoring that negative 2 out. What does that leave me in my middle parentheses? An x minus pi over 2, right? We're dividing a 2 out. X minus pi over 2, and then we still have the plus 2 on the very end. And because this is an even function, this negative right here can go away. The value I get with the negative in there is the same value I'm going to get with it out. So I can rewrite this as y equals 4 cosine of 2 parenthesis x minus pi over 2 plus a 2. All right, so let's analyze this one. What do we know? Good. Amplitude is 4. Period is pi. Everybody okay with that? Right? 2 pi divided by 2. Increments would be pi over 4. It's good. Phase shift. All right, so we're going to go right pi over 2, and last piece, we have a vertical shift of, okay, so let's get our dotted line put in the right spot. We have a vertical shift up 2, whoops, moved the wrong piece, come on. All right, so we're going to go up 2. What about our range? We went up 2, and then our amplitude we said was 4. So if we add and subtract 4, we're really going to bounce between -2 and +6. All right. So from here to here. All right, let's look at our phase shift. We said we are moving to the right pi/2. Our increments are in pi/4s. So right 2 spaces, right? Pi/2 would be 2/4 from 0. That's going to be where I start. Each increment goes up by 1/4 pi. So if we're starting at 2/4, my next tick mark would be 3/4. My next would be 4/4, which is just pi. Then I'm at 5/4. And then I'm at 6/4, which would be 3/2. Okay, let's check to see if that's right. We have a 2 parenthesis x minus pi/2. Whoa. And we start normally at 0 and stop at 2 pi. Again, notice because the 2's been factored out, we have to divide it out first. So we're going to divide both sides by 2. We get 0 is less than or equal to x minus pi/2, less than or equal to pi. And we're going to add pi/2 to both sides. 1 pi plus another half would be 3/2. So are we getting a start and stop where we thought it should be? Okay. All right, and it was cosine. So cosine starts high. All right. So our high point we said was up here at 6. Our new 0 is here on our dotted line. Then our low point we said would be at -2. Then we're back at 0, which is actually at 2 now, and then back at our high point. So does it look like I'm bouncing the same space above and below that green dotted line? Okay, and that should always happen. It should be the same distance up and down from that dotted line. It's just not at the x-axis anymore. Okay, give me a real quick, where are we at on a scale of 0 to 4 with all this vertical shift stuff? Okay. All right, we have 3 quick examples, but these are already graphed for us. They're asking us to come up with the equation based on the picture. Okay. So in our equation, we need to know an A value, a B value, an H value, a K value. So let's start breaking it down. What can you tell me about the amplitude? Everybody okay with that? We're going up 2, down 2? Okay, so our amplitude is 2. It says that it is a sine curve. Okay, now, in order to figure out is this amplitude, is it really a 2 or a -2 for A? We have to decide, has it been flipped over the x-axis or not? So let's think about a normal sine curve. We normally start at 0 and then go high. So let's find a part on our graph where we're starting at 0 and we're going high. Okay? That would be 1 period. Yes? I could have started at the 0 where I ended here, but I don't have enough of my graph to continue that out. Does that make sense? That would be the 1 section where I've got the whole period. So tell me what I've done to it. Have I reflected it? No. So my A value is just going to be a 2, not a -2. But I have shifted it where? I've shifted it so that my starting point is left pi/4. Okay, so my H value is going to be pi/4. Well, I'll say it a different way. I'll just write left. You're right. It's going to be a positive in our equation. We're going to go left pi/4. Okay, how long is the period? if we're starting at negative pi over 4 and we go up to here, which is what? 3 pi over 4? What is that space? From negative 1/4 to 3/4. That's 4/4, right? So our period is 1 pi. What does that mean our B term was? Yeah. Okay. Have we moved it up or down at all? Our zero line is really looking right at like it's on the x-axis, right? So our K value would be 0. We didn't have any kind of vertical shift. Okay. So we have enough that we can actually write our equation now. We said our A value was 2. It is a sine curve. We said our B value was 2. And we said that we are going left pi over 4. So I'm going to have a plus pi over 4 in here. Now notice that I factored that red 2 out, right? When you identify a phase shift like we did here, that's assuming B has already been factored out of it. So this is one way you could give me your answer. What would be another version of this? 2x plus pi over 2 if we multiply the 2 back in. Okay, and we're used to seeing it in both orientations. So either one would be okay. If it was a multiple choice question, you'd need to understand those were equivalent. Okay? All right, next one. It's multiple choice. Let's look at our options here. We have A values of 3 and negative 3. So we have to decide, has it been flipped or not? And have there been any kind of left or right shifts? Looking at our options for answers. Hang on, look at your options for answers. Was there a left or right shift? No, there's no H value over here. Is there a K value over here? On any of my A, B, C, D options? Okay, so we aren't looking at any kind of vertical shift. We aren't looking at any kind of left or right phase shift. All we're doing is identifying a period change because there's numbers in front of X. Okay, so there's a B value that we have to figure out, and there's an A value that we have to figure out. Let's start with A. This is a sine curve, and we said there is no phase shift. So a few of you started to say, yeah, it went left because you're looking at this part. But in my options, I didn't have an option of a phase shift. So I can't think of that as being the piece I'm supposed to analyze. I have to say I'm starting here. And because I'm going down first, what does that tell me? That A has to be negative. Have I gone 3 up and down from 0? Yes? Okay. So my A value has to be negative 3. Should use a capital for that. All right, so I can eliminate those two right away. Now, for B, let's look at the period. Period goes from 0 to pi, right? What does that tell me about my B term? That B had to be 2, right? Because it's always 2 pi divided by B. So which one is the correct answer? C. All right, our last one. Look at your options for answers first. It's going to clue you into what parts you need to be analyzing. Our options are 5s and negative 5s, and there is a B value somewhere in my equation. Are there any H and K values? All right, so we are starting at 0. We're doing one sine curve. There's one period. Have I reflected over X? No, I went from 0 to my high point, so there's no reflection over X, which means I can eliminate my negative options. Okay. Do you agree that the 5 is correct here? Okay, we have an amplitude of 5. Now, for my B term, where do I start and end? I start at 0 and I end at 2. Yes? So the period, this one's a little different. My period is just plain 2. It doesn't have pi in it. So when I look at what b has to be, period is supposed to be 2 pi divided by b, but I'm supposed to get just a plain 2 for an answer to that. So what is b going to have to be? It's going to have to be a pi. So if this was a pi in here, the pi's would drop out. So I need the function up here where a b term is pi. Does that make sense? All right. So we have one more day of a couple more examples for tomorrow, and then we're finally finished with this and we're moving on to other types of trig graphs. Notice in the homework tonight, questions 62 to 68 even, I want you to graph those as well. So I'm going to get you some graph paper while you write this down.